Okay, so we're going to talk about orbital notation now. I sent by email a couple of links on a couple of videos. One of those videos deal with electrons, and I would recommend that you watch that video. Okay, we're not going to take time in class to watch it.
What video?
I just said I sent it to you, sent the link to you by email. Okay, now, so, what? Orbital notation. Orbital notation. And if you look at that video, you'll find what I'm about to show you at about 7:12 on that video. And what I'm going to show you here is a chart that is helpful for figuring out how to write orbital notation and electron configurations. Now listen, I'm not going to give you this on the test. I'm going to give you a chart that's easy to remember, but if you're going to use it as a tool on the test, you have to memorize it, but it's not hard. Okay? Here's what you need to do. Nice and neatly write 1s, and under that write 2s, and keeping it neat and evenly spaced, write 3s, 4s, 5s, 6s, and 7s. What now? Yeah, it's kind of like writing on separate lines. Okay? Now then, right next to 2s, I want you to write 2p. Leave a little space there and write 2p. And under that is 3p, and 4p, and 5p, and 6p, and 7p. Okay? On this row where 3 is located, 3s and p, leave a space and write 3d. And under that is 4d, 5d, and 6d. Now we could write 7d, but really that's really kind of going too far. We don't need it. Okay? Yeah, the letters are actually lowercase. You could if you want to, if it helps you. Well, you won't ever get to 7d, but that's okay. All right? Good. Then you have some experience with it. All right? Now, on row 4, we're going to write 4f. If you want to, but you don't have to, because we're never going to get that far. 4f and 5f. Now then, if you're going to use this, you probably ought to have a highlighter of some kind to help you, because what we want to do is to write arrows at a 45-degree angle or close to it. Well, you'll have to use something if you want to write the arrows. Okay. All right, so this is a pattern that might help you, guys. You need to pay attention here if you're going to be able to learn this stuff. This is a pattern that might help you. Okay? And we'll get to why it can help you or how it can help you shortly. All right, we're going to start with the very first element. Get out your periodic tables and make sure you have at your hands, right close by, the periodic table outline that shows the orbital regions. You need this one, and you need the periodic table. Okay, you need both these. You need your periodic table, and you need the orbital regions outlined. You need both those tools to help you with this activity. Yes? Sure. I'm sure you can. You also may. All right. Now, what is the first element on the periodic table? Hydrogen. So we're going to start with hydrogen. It's the first one. And we want to write its orbital notation. So hydrogen is the element symbol. I want a colon after the element symbol. So this is just showing what this applies to. It's not the actual orbital notation. Anytime you're writing an orbital notation, however, it is required that you write the element symbol followed by a colon before you write the orbital notation. Okay? Now, we are going to represent orbitals as squares. That doesn't mean that orbitals actually form squares. We're just using the squares as a place to record where electrons are located in a kind of inventory. We're going to use squares to represent orbitals, but you need to know that orbitals don't actually form squares. We're just using squares as a place to check off where our electrons are located. Okay? But what we're going to do is we're going to look at where hydrogen is. Okay? What period is hydrogen in? Period 1. Each row of the periodic table represents a period. Remember, rows are periods, columns are families or groups. Each row is a period, so hydrogen is in period 1. Now the reason that's important is that the first electrons in the lowest level, right next down to the nucleus, is where period 1 is located. It's at energy level 1. So our first electron, it has to be in, or this only electron for hydrogen, has to be in primary energy level 1, which corresponds to, is not, I mean it's the same thing as, but it corresponds to that period 1 on the periodic table. Now, if we look at the orbital regions, what orbital region is hydrogen located in? S. So the first electron, the only electron in this case that hydrogen has, is in a sublevel we call S. Now, you need to know this. S sublevels, and it's a lowercase s. S sublevels have only one orbital. And we're going to represent orbitals, remember, as squares. Alright? So above 1s, that's where we're going to put this orbital symbol. Okay? And then we will represent electrons in orbital notation. This is the only time this is used, but in orbital notation, electrons are represented by arrows. If hydrogen has one proton, and we know that because that's the atomic number for hydrogen, if a hydrogen atom has one proton, it must have how many electrons? Just one. So we only need one arrow, and so we're going to point that arrow up. Okay? Yep. Yes. And we're done. That's the orbital notation for hydrogen. All right, now we're going to go to what element? What's second? Because that represents the electron. Mm-hmm. One up arrow. Okay. Helium then is the next element. And what period is helium in? 1. And what sublevel region, what orbital region is helium in? Huh? S, because we moved helium from over here to here. Okay, it's in the S sublevel region as well. So the next this electron is going to go in 1s. Orbitals, and that's what that box represents. Can hold a maximum of 2 electrons. They must have opposite spins. So here's our representation of an orbital in orbital notation. The up arrow represents a spin. That's why we use an arrow. Up arrow represents a spin. So if I'm going to put a second electron in here, how do I represent that opposite spin? A down arrow. And we're done. That's all the electrons in helium. We don't need to do anything else with that. Now the thing to remember is all atoms that follow have to have all the electrons in all the orbitals we had before. So every atom that we build orbital notations for after these are going to have this 1s orbital with 2 electrons in it. Okay? And we're going to add electrons above that. Got that? Alright. So what's the next atom we come to after helium? Lithium. And that is L, lowercase I. Capital L, lowercase I. Remember, it's very important to make sure your cases on your letters are very clearly capital and lowercase to write an element symbol. Not the helium. The helium is still in 1s. It's in the first row, represented by the first primary level. Remember, we moved helium from over here to over here. It's part of S, but it's in the first row. That's 1s. Okay. Now lithium's going to have those same electrons, so we can go and write the same number of electrons we have for helium. Okay, so there's 1s. What? Spin. You know, spin. Round and round. They represent the spin? You know what? Let me do lithium since I started here, and I'll come back and explain the spin, okay? That's a good question, yeah.
Wouldn't that be in the second sublevel?
Absolutely. You mean the second primary energy level, right? So the second energy level, and that's what we're going to do next. Okay, so very good note. You notice something very, very important. Lithium is in the second period of the periodic table, so it must have electrons being filled in the second primary level. So this next electron, lithium has 3 protons, so it must have 3 electrons, and the next electron we put in there for lithium must not be in 1, it must be in primary level 2. What sublevel region, what orbital region is lithium located in? It's still an S. How many orbitals can you have in an S sublevel? Just one. And if I'm going to have all the electrons that lithium needs, how many more electrons do I need than I have right now? I need one more. It's got 2 now. I need to have 3 electrons to correspond to those 3 protons shown by the atomic number. So I just need 1 electron with an up spin. So Olivia asked, what is a spin? So this gets a little bit complex, so bear with me a minute, okay? Try to listen and pay attention and understand. Did any of you do pith ball demonstrations or experiments when you were in physical science? Don't remember that? Do you remember what happens when you put 2 things next to each other that have opposite charges? They repel. Things with the same charge repel. Things with opposite charges attract. Okay? It's just like the north and south end on a magnet, in a sense, in that the north end of a magnet is attracted to the south end. That's opposite. But a north end is repelled from a north end. You ever seen that happen? Okay. So charges are like that. Charges have electromagnetic fields around them. So electrons have a charge. They have a 1 negative charge. If I just put two electrons next to each other, they would want to spin apart or spread apart or fly apart. Okay? The way that we cancel that repulsion is by giving the electrons opposite spins. Now, why is that? Well, maybe the easiest way to explain that is if I have an electrical signal going down a wire, so electrons are flowing down the wire, let's say in this direction. Because they're going in this direction, the electromagnetic field spins around that wire the same way my fingers do on my right hand. So if my thumb points in the direction the electrons are flowing, then the electron field or the electromagnetic field flows in this direction around it. Okay? If I put this wire with electrons flowing in this direction right next to another wire that flows in the opposite direction, then I've got a field going this way and a field going this way, and they cancel out. So the same principle applies to the spins. If I spin one electron in one direction, then I spin another electron in the other direction, presumably those electromagnetic fields cancel out, and you can put two of them in the same region. Does that make sense? Yes?
I don't get how everybody cancel out.
Yeah, that's kind of deep. So let's don't go too far with that. That's more of a physics concept. Yeah. Yes? Well, you may go to the restroom. All right, let's go to, what's the next element we go to?
Hold up, so Mr. Turner, so you said in the first row you can only have two spins?
In any orbital, an orbital can hold a maximum of 2 electrons, and they have to have opposite spins.
Okay.
So how many more electrons can I put in this orbital? Just one more. Let's do beryllium. So I've got to have all the electrons I had in there for lithium. So all this stuff has to be continued.
Are we going to do all of them or just a couple?
We're going to do a lot of them, but not every single one of them. Okay? But now, beryllium is located in what sublevel or orbital region? It's in the second primary level, the second period, but what sublevel or orbital region? S. It's still an S, so where do I put the next electron? Beryllium needs 4 electrons. Opposite spins. There it is. Yeah, but we gotta have other orbital regions too. See, we've got S's here and P's over here, which brings us to the concept of what we're going to do about boron, because boron's right over here in this top left corner. Okay, so that's our next element. Here's boron. Now, boron has to have all the electrons and all the orbitals and all the structure we had in the previous element. So we've got 1s. I'm going to start using half arrows because it's faster. Is that okay with you guys? I'm not going to confuse you if I do that. Instead of having both sides of this arrow tip, I'm just going to put 1/2 of the arrow in here. Okay? So here's 2s. Okay? Alright, those are the electrons for beryllium. Boron, however, is not in the S sublevel region. What sublevel region is it in? P. What period is it in? No, it's still in 2. See? Second row here. First row is right up here at the top, then boron's in the second row, which means in the second period. And since sublevel or orbital regions are talking about adding electrons to orbitals, that's what this pattern shows you. It represents where electrons are being added to the electron structure. Then because boron is in the p sublevel region And in the second period, that means we're going to be putting new electrons in 2p. All right? Second row is 2. P is the orbital region. Okay? All right, now, the p suborbital region doesn't have just one orbital. Yes? All right, a p suborbital region has to have 3 orbitals. This represents the 3 orbitals in the p suborbital region in the second primary energy level. The second primary energy level, represented by boron being in the second period of the periodic table, the second row. The p suborbital region or orbital region is represented by where it is located on the periodic table, in this region over here. Boron's right in the upper left corner right here. Okay? Now, beryllium had 4 electrons. How many electrons do we need for boron? 5. Where am I going to put the next electron? First box. What direction? Up. Always up first. Okay? Always up first. Okay? But now we're getting into a place where we've got to figure out whether we put the second electron here or here. And here's the way I'd like you to think about it. And it's called the school bus rule. All right. So let's say that Kenya is going to school on her very first day, and she's riding the bus, and she's the first person to be picked up on that school bus route. Okay? So Kenya gets on the bus. What seat does she sit in? The first one she gets to. Just like this. We're going to say you sit in the first one. Okay? For this. All right, now. Then Micah is the second person on that route. This is his first day at school. Never been to school before. He gets on the bus and he doesn't know Kenya. Okay? Where's he going to sit? Second seat. All right? Not on the first seat. All right, it's a little bitty bus, by the way. It only has 3 seats. Okay? Little bitty tiny bus, only 3 seats. All right? So Kenya's sitting here. Micah's sitting here. Okay? Huh? No, they're going to be pointing up. First one in the box always up. But we're not there yet because this is boron. Boron doesn't need any more electrons. We're talking about the electrons that follow. Okay? Got it? All right. So then, let's see. Zach's the third person on the route. His first day at school, never been there before. 3 seats in the bus. He gets in the bus and he doesn't know Micah. He didn't know Kenya. Where's he going to sit? He's going to sit by himself. He's not going to sit by you. He didn't know you. He might be worried about you biting him or something. It's not going to happen. All right. All right. Then Olivia. Olivia's the next person on the route. First day at school. Doesn't know any of these people. Where's she got to sit? Huh? Well, but how many people can you put on a school bus seat? 2. Where are you going to sit, Olivia? All 3 seats have 1 person on them. You got to sit with somebody else, so you got to sit here. Okay? Yep, there you go. All right, good point. All right. This is the way we're going to fill up P and D sublevels. Okay? You're going to put 1 arrow in each box, and then once all the boxes have 1 arrow, we can go back and pair up arrows to fill the rest of it. Okay? But this is boron. That's all the electrons we need for boron. But it tells us how to fill up boxes for the next element, carbon. So we've got to have all the electrons we had for boron. So up, down, and then 2p, just like the students getting on that bus. They don't know each other first day of school. 1 on 1 seat and 1 on a different seat. Okay? and that's carbon. All right, then nitrogen. I bet you know how to do nitrogen already, don't you? Why don't you try nitrogen for yourself? I hope you're writing in pencil. If you make a mistake, it's easy to erase.
Nope.
Write nitrogen for yourself, and then I'll do it, and we'll see how you did. One of the best ways to learn is to try it for yourself first. Nitrogen. It's the next element. The very next element. So carbon had 6 electrons. Nitrogen has 7. Carbon has an atomic number of 6 for 6 protons, so it has 6 electrons. Nitrogen has a proton number or atomic number 7, so it needs 7 electrons for a nitrogen atom. Okay, atoms have to have the same number of electrons as protons. Ions will be different, but that's atoms, okay?
The little number.
Olivia, chemistry wizard. Yep.
So if it has like 6, I'm just going to, okay, so it's an oxygen. But you put like another arrow, a down arrow on it.
First box.
Yeah, the first box.
All right.
Do that for each number.
You just keep going in the same pattern. That's not it. Really, once you figure out the patterns, it's really not hard. All right. Everybody got their attempt on paper? How'd you do? Good. See? You said you didn't know this stuff. All right. Now, so here's what Jacob was asking about, or Jason was asking about. If I have oxygen, which is the next element, where's the next electron going to go?
Another box.
You can't put another box in P. P only has 3 orbitals. The down arrow in the first box. Now you write oxygen. Write oxygen. Try oxygen, please. Try oxygen. No, why? I think I got it. Everybody got it? If you're still working, raise your hand, let me know. All right, seeing no hands.
Wait, I raised mine.
Yes.
It's nothing like this, but what happens if you put a match in a gas tank?
What? Match in the gas tank.
Well, actually, two things can happen. It can blow up or not, right? Or catch fire or not, right? Okay. You can actually take a match, and especially on a cold day, and throw it right into the gasoline, and the match will just go out. Yep. Because you have to have a mixture of fuel and air in the right ratio. So if you just throw it right into the fire, into the gasoline, it'll put the match out because there's not enough oxygen. Okay? The gasoline doesn't light up in that liquid pool of gasoline. It lights up in the gas or vapor above it, where there's a mixture of gas and oxygen. Okay? So it is possible to toss a match into gasoline and it not catch on fire. All right. How we doing? Y'all got it right? Great. Great.
So how does one help us or whatever?
Nope.
Those arrows mean?
We're going to keep going. What now?
What those orange arrows mean?
Okay, that's a good question. Take a look. We filled up 1s first, then 2s. The next thing we came to after we filled up 1s and 2s was 2p. So 1s, 2s, 2p. And we finish this row, we'll be in 3s.
So what if you want to show us the order again?
This is how you can predict the order fairly easily. Okay? We'll get to that when I get to 3s. I was going to show you then, but that's fine. We're good now. Okay?
How does one help us?
How's this going to help you? You need to know the electron structure. The state of South Carolina says you're supposed to know the electron structure of an atom. But it also helps you when we're trying to figure out why atoms bond the way they bond. Okay? All right. Morgan, come on up here and show everybody how to do fluorine. Yep, everybody's going to be called out. Come on. Come on, Morgan. Come on. No, don't let Morgan start. Come on, Morgan. Y'all, come on, clap right here. Come on, help her out. Come on, Morgan, let's go. Come on, Morgan. Come on, girl, let's go. Show us how to do it. Sure, why not? Hey. All right, stop talking. You should be helping Morgan and not talking amongst yourselves. You can stop talking so you'll know. Fred, come on, man. You right there in front of her now. Help her out. Fred.
Okay.
Okay, it would be a real good idea while she's doing that, and y'all are helping her, you also read the red note over there. But you're not using your calculator right now. Put your phone away.
I don't. What is the 3 box? And then what? And a down arrow? In the same box? And
Okay, awfully small, but if you can make it out, you did a good job. What are you going to do? Pass it up. All right, your attention should be up here. Helping her out if she needs it. Sure. I might need to kind of help you get started with it, but that'd be great. Sure. Oh, she makes such a nice neat arrows. Look at that. All right. You don't have to be all right.
me because I was in chorus.
Are y'all paying attention up here? Y'all know if she's doing this right?
Yep.
Here's our chemistry wizard. Here's our chemistry wizard.
Okay, what's the element?
Well, let's see. Now we got to go to sodium. Yes. Next row.
That's Na, right?
Yes. I got to the periodic table sitting right there. It's probably the next to right hand.
Oh. God, where is it? I was just kidding. Lord. Hang on a second. Wait.
Okay, pay attention to what she's doing. Your job is to make sure she's doing it right and to copy down the work.
Are we supposed to write this too?
I would. Huh?
Oh, you should have done that, Mr. Kevin.
Well, y'all can do it yourself and see how it compares, right?
I don't know if,
Or is it? I can ask for
I don't know if that rifle's supposed to be connected to it or not. I was just kidding.
No, it's not supposed to be connected. You do right. Label them now. 1S, 2S.
Oh, I don't know how to do that.
Oh, help her out, somebody.
That's the first box is 1S, the second box is 2S, the third box is 3P, and then the fourth box is
It's 3S.
3P, right?
3S.
I mean 3S.
Oh, my ring looks
Cody
pretty
region,
good.
S sub-O region. What?
What is it?
That box by itself is 3S. It's in the third row. That's where the 3 comes from. It's in the S sub-O region. That's where the S comes from.
Yeah.
Well done. Who wants to go next?
I'll go.
All right, Dennis. You can go next. Huh? Let her go? Okay, go ahead.
Go ahead, 7. I got a question first. Oh, it's working with Halo. I know. Working, girl.
What am I doing? NA. Oh, MG?
Yes, ma'am.
Oh. What? What? Oh, yes. Oh, wait, so moved.
Yeah, it's on wheel.
Oh. Where'd I go? Is that locked?
Michael, put her phone down now.
You said what? Something like that.
I don't know if we're going to have time. We might have time for one more.
We do?
Maybe. Huh?
5 minutes. 5 minutes. 5 minutes.
Depends on how fast Michelle gets done.
Okay, that's it.
Line up a little bit, Michelle. Let's see it. All right, how'd you do, guys?
Very well.
All right, who's going to do the next one?
I'll do it.
All right, so this will be aluminum, or if you were in Britain, it'd be called aluminium. So, so your homework then is to do the orbital notations on a separate sheet of paper for silicon and phosphorus.
That's it?
Silicon and phosphorus. Your homework will be to do orbital notations for silicon and phosphorus. He's going
my
to do
finger.
aluminium.
What? Which one we do? Aluminum?
Orbital notations for silicon and phosphorus. So please, I've asked you, I've been clear about it. Texting during class is making you double-minded. Focus on what we're doing, okay? Okay. I'm not writing up today. I'm just letting you know, be clear. Thank you very much. I'm proud of you. I really am. I appreciate it so much. You don't know how much. Oh my God. Yeah, and look, you're the chemistry wizard today too, aren't you?
So that.
It's amazing how much better you get at this stuff when you're actually focused entirely on what we're doing in here.
Oh, that's an error, never mind. Yeah.
Oh my God, you
gotta have 3 boxes. There's 3 orbitals in a field level. Even though they're empty, they gotta be there, okay?
Yeah.
Alright, slide it over so people can see. To the right.
Oh.
Right. There you go. Alright, check it out. There's the pattern. And you follow through like that when you get there. These have 3 boxes, S's have 1, D's have 5. 1, 3, 5, odd numbers.
1, 3, 5.
We'll get to that. We ain't got
We got homework. Y'all just go up now.
Oh my gosh, yes, that's correct. Very good. Oh, you need to have it on a separate sheet of paper though, so you can turn it in. Oh, that's right. Hold on, let me write this down. Yep. I'm